so today we're going to move on with more limit stuff. In particular, turn on the clicker, and then talk about infinite limits. We have two different types of infinite limits. Today we're going to do the easier ones. Tomorrow or the next day after that one, we'll do the more difficult ones. But the more difficult ones really aren't that difficult. Nor, I think, when you find this that difficult, but time will tell. Okay, so we're going to talk about infinite limits from the left or from the right. In particular, we're going to look at limits around asymptotes. So we're going to make sure that you know how to find the asymptotes and then decide what happens on the left or the right. We're going to do some sketching. We're going to not get tricked in thinking that you're dealing with an infinite limit when in fact you've got a plug and chug going on. And then of course you should always look both ways before you cross the street, unless you get run over. All right, so get out your little grapher things, your graphing utilities, if you will, either your iPads and Desmos or your graphing calculators, and graph that puppy, please. You might want to put that top in parentheses. I don't necessarily know if you have to, but you should definitely put the bottom in parentheses. As a PEMDAS. Okay, you got it?
No.
How about now?
No.
No? Yes?
No.
How about now?
Yes.
Got it yet? Still working?
No, it's good.
Almost? You got it. You're good? Okay, great. What can you tell me about asymptotes in that picture, Michael?
There's one at x equals -2.
Okay. Is that it?
X cannot equal
Okay. So you seem to have contradicted yourself there, my friend.
looking closer to -3.
So you're saying there's an asymptote at -3?
Yeah.
Agree or disagree? Disagree. What do you got? What do you got, Faith? Huh? Huh? Yeah, that's what I thought. Let me ask you again. Agree or disagree? Agree. However, anybody else want to contribute? Are there any other asymptotes in that picture? Hey, what do you got?
There's a horizontal at 3.
You bet there is. We'll talk about that later. We're going to focus today on that asymptote at -3. Is it safe to assume you all understand why there's an asymptote at -3? Beautiful. In your notes, please write down, based on your picture or on the function itself, some interesting limit questions you would want to ask. What is the limit of that function as it approaches? I don't know. What numbers would be interesting to you? And what directions would be interesting to you? Okay. For those of you that chose to actively participate, which is about 2 of you, Ben, what do you got for me? What would be interesting?
What is the limit of that equation? Is that -3? -3.
-3?
Yes.
From the left, from the right, or from both?
Both.
From both. That would be interesting. Do you know the answer? Okay, what about if you approach from the left?
-3.
What if you approach from the right? What if you stand up, sit down, fight, fight, fight? Okay, good. What happens when X gets really big in that picture? And I'm talking really big. I'm not talking 10 or 1,000. I'm talking freaking big. Like way, way over to the right. Like you'd have to sit and scroll for a long time to get over there. What Y value is it going to approach? 1, 3, 3, 5. Ben, are you scrolling? You making any progress? What's it getting close to?
Yeah, I'm gonna go 3. I'm gonna go 3.
Okay, so go to your table on your, for those of you that graphed it on your calculator, go to your table and start scrolling. And as you start to scroll down, you'll see that you start with something like 2.5 something, 2.8, and as you continue to scroll, scroll in, what's it getting close to?
3.
It's getting really close to 3, but you got to go a long ways before it even, well, will it ever hit 3? No. Why not? It's an asymptote, can't be equal to 3. We'll talk about that a little bit later. Now, the question is, could you do all of that? Well, if you chose to do that, because many of you chose not to. But if you had to do that, let's say on the next quiz, could you do all of that without the picture? You think so? So there's a picture of a similar function, 3 over x minus 2. We realized, what we've already discussed, that there would be an asymptote at 2, because the denominator cannot be 0. The trick here is going to be, without looking at a graph, even though I've given you a graph, are you going to be able to tell what happens around the asymptote? Okay, which direction it's going to, is it going to increase or decrease without bound? And like it says up there, that's the fancy way of saying it goes to infinity or negative infinity. So, for instance, if I give you that graph, or sorry, that equation, without graphing it, don't cheat, you should all be able to tell me where the vertical asymptote is, yes? Donde? 1. Beautiful. Any problems there? Hot diggity. So, write the following limit down. What is the limit as x approaches 1 from the positive side of f of x? If it's an asymptote, you have only 2 answers, infinity or negative infinity. But how are you going to tell which one it is without a grapher? Could you explain a little bit more?
Like if it was x plus 1 squared, it would be at -1, so would it be, I don't know, I'm guessing.
Maybe you didn't understand the question. Let me give it to you again and see if. So we know there's an asymptote at 1, yes? And if I approach 1 from the right-hand side, from this direction, is it going to curve up or is it going to curve down?
Up.
Why?
Wait, it's above us, so when we go down, are we doing it, I don't know. Above?
I don't know. Ben?
Squared.
Why?
Because it's whatever you get out of that, it's going to be positive after you square it.
Outstanding. So there's 2 different ways to look at this. One is this particular function has a square term in the bottom. So no matter what I put in there for x, I'm always going to get a positive value. Okay. But let's let's just look at a number slightly to the right of 1. Let's say 1.1. If I put 1.1 into that function, 1.1 minus 1 is positive or negative? Positive. And when you square a positive number, you get a positive number. Now suppose I make that number smaller. In calculus, 1.1 is not very close. Okay, that's really far away actually with some of the stuff we do. So if I take a really, really small number that's really, really close to 1, like 1 point with 34 zeros and a 1 at the end, will my answer be positive or negative? Positive. And then you square it, you get positive. So what happens when the denominator of a fraction gets close to 0? What happens to the fraction itself? I heard somebody say it. It gets really big. Right. So we take a fraction like 1 over x. As x gets very close to 0, that fraction gets very close to infinity. In fact, goes to infinity. As the denominator gets very big, the fraction gets very close to 0. Okay. So let's go on the other side. We take a number that's really close to 1, but on the left-hand side. In other words, what's a limit as x approaches 1 from the negative of f of x? Okay, so we put in like 0.99999. Positive or negative value in the denominator. Well, 0.99999 minus 1. Is that positive or negative?
Negative.
Negative. And you square a negative?
Positive.
Positive. So what have we learned?
It will be positive.
What's the graph? Show me with your hands what the graph looks like, because this will look good on the video. Correct. Okay, good. It goes like this. Right? What about that one? How is g of x different than f of x? It's not squared. We go through the same process, however. Where's the asymptote? 1. Go to the right of that asymptote, 1.1, you get in there, you get Let me ask my question more specifically. If I put 1.1 in for x, what happens to the denominator? Positive or negative? Therefore, g of x is negative because there's a negative on top. So, will the sorry. If this is the asymptote at 1, is my curve going to go up or is it going to go down? Down. Good. What about on the other side? Put in 0.99999. Denominator positive or negative? Negative. Negative over negative is?
Positive.
So show me what the graph looks like around 1. Good. Oh look, there it goes. Before I show you the other picture, let me ask you a question. And we answered this already, but I want to make sure we're all on the same page. What's the limit of f of x as x approaches 1 from the positive side? Infinity. Good. What's the limit of f of x as x approaches 1 from the negative side?
Infinity.
So therefore, what's the limit of f of x when x approaches 1? Beautiful. Why? They're both the same. Left-hand limit matches right-hand limit. What's the limit of g of x as x approaches 1 from the positive? Negative infinity goes downward from the negative side. Infinity. What's the limit at 1? Does not exist. Left-hand side does not match right-hand side. Now there is this weird scenario where infinity is not an acceptable answer because people would argue it's not a number. It's a concept. Whoops, it's a concept. I don't care. We know what infinity means. I agree with what we've already said, that on the left-hand side, it would be infinity. On the right-hand side, does not exist. Okay. And again, the big question is, are you going to be able to do that without graphs? Can you find the vertical asymptotes, and can you determine what the graphs look like on the left and the right-hand side of that asymptote? Okay. So, what generates a vertical asymptote? We've done a bunch of them, but put it into words. How do you know where the vertical asymptote is? Beautiful. It's what makes the denominator equal to 0, which is what all that says up there. in fancy calculus speak. Let f and g be continuous on the open interval containing c. If f of c does not equal 0 and g of c equals 0, there exists an open interval containing c such that g of x is not equal to 0 for all x not equal to c in the interval, then the graph of the function is given by the has a vertical asymptote of x equals c. Which means c is the value that makes the denominator equal to 0. You already knew that.
Write all that down.
Yeah, write all that down. We'll wait. Go ahead. That was sarcasm. Don't write all that down. Do you know what makes a vertical asymptote? Beautiful. Okay. Just because it's in a blue rectangle doesn't mean you have to write it down. Where's the vertical asymptote? Just because I'm feeling saucy. Does this have a horizontal asymptote?
Yeah.
Where is it?
0.
Are you sure?
Yes.
Huh. You think so, huh? See? How about that guy? Oh, yeah. Negative 1 and 1? What about canceling? Can't you just cancel the x squareds? Come on, people do it all the time, it must be right. You just cancel the x squareds, you get negative 1. Then you graph negative 1 and you're surprised when it's a horizontal line. Okay, so factor the top and factor the bottom. Can't factor the top, you guys are too smart, I can't. Uh-oh, yeah, he went there. Everything's going along dreamily, and then the big idiot throws some trig at you. Where are the asymptotes for the cotangent? Not only, well, first of all, for cotangent, how many vertical asymptotes are there? A lot. The mathematical term for a lot is infinity. So not only should you be able to tell me where a couple of them are, but you should be able to write a phrase or a sentence or an expression that would describe all of those asymptotes. Where are the asymptotes for cotangent? Cricket, cricket, cricket. Which one? Pi over 2 or pi? Pi? Pi over 2? It doesn't matter. If I just repeat it as a question, you're going to change your mind anyways. What color is the floor?
White.
Blue.
Yeah.
White specked with blue?
Yeah.
No, it's green. Where are the asymptotes for cotangent? Pi. And? 0. And? 2 pi. And? 3 pi. And? 4 pi. How do we summarize that? K pi. Okay, we're done. So what we're going to do tomorrow is we're going to come back to this, let's say B for instance, and we're going to look at, we'll already know where the vertical asymptotes are, but what we're also going to look at is whether or not it has a horizontal asymptote, because what we're going to do is ask ourselves the simple question that I asked here, and that is, what happens when x goes to infinity? What happens when we move very far away from the origin? What y value does the graph approach? And obviously you're not going to have your calculator to do that all the time, nor are you going to have the time to just sit there and scroll to figure out what that answer is, so you have to be able to find that value mathematically. Okie doke. Questions? Beautiful. I told you it wasn't that bad. This is pretty much just pre-calc, but we threw the term limits in there, which freaks some people out.
Anyway, good. It's so much better when I don't have to explain it.